Hello everyone. So in today's lecture we are going to see how to format the output in the MATLAB. And when we say how to format the output in the MATLAB, that means when we see the output of any function or output of any operation in the command window, then we want it to be represented in certain way. So let us start and see what we are trying to read here. So for example, if I type pi and check the value of pi, I get 3.1416. In this case, the value of pi is up to 4 decimal places. Now in case if I want the number of decimal places to be more than 4, then I will change the format option to long format. And once I do that, and if I check the value of pi again, then we can see that we have around 14 decimal places. So yes, we will have 40 decimal places and total 15 digits in the output. So this is what we get in the output when we use the format long. So it can be applicable at any case, like if we are doing some kind of calculation within a function, and then we want the output to be displayed for more than 4 digits after the decimal point, then we can use this format long. So what was the default format earlier when we were getting 3.1416? So it was format short. So if I write it the format short and then I again check the value of pi, it is going to be 3.1416. So in any case, if we have changed the format to something which is other than the default value, then to get back to the default value, we will simply write format and press enter. So this will take us to the default value. For example, when we changed to format short and then we checked the value of pi, it comes out to be as 4 decimal places after the decimal point. And when we change to the default format by typing format command, then we get the same value. So this means to say that the default format of output is format short. Now, depending upon the applications, we may want the output to be written in different forms. For example, format short E, this is the engineering format. So if we want output to be written in engineering format, then we use format short E. So if we want the output to be short but written in engineering format, then we will use this format short E, and we get the result for the pi as this 3.1416. This is e to the power 00. This short E can also be written as format short capital E without any spaces, and it is the same thing. So format short E and format short capital E and short ENG are all the same. Now in the same engineering format, if we want the format long, then let us use some other variant. We will use long capital ENG and then press enter, and then we will check the value of pi. So this is what we are getting here. So it is giving us 3.1415 and all the values and E plus 0000. Now if we want to get back to the default format, so we will do this format, and then again if we check the value of pi, we are getting it what it used to be. Now let us see where we can use this formatting. So this can be used in cases like this, where we have a vector x and the values that we have here is a purely integer. Then there is a number with 5 digits after the decimal point, then we have a bigger number, and then we have a very large integer value. So we will see that how it is being represented in all the formats. So before that, we will just clear the screen of the command window, and we will run and execute the vector x. So the x vector is this, what we are seeing here. So it is 25.56.31156.255.52675. So it is as what has been given in the command. but it is displayed in this manner. So we will start with the first format. We will say format short, and then we will check what is the value of x. So you are getting what we have got already. That means the default format is format short, and so when we executed this particular expression, this particular statement, the value that we got in the output was this, and it is in format short because when we changed the format to format short and checked what the value x is represented in this particular format, it is coming out to be same as it was shown earlier. Now we change it back to format long, and then we check the value of x. So you are seeing that when we do this, when we change this format to format long and we check the value, we are getting something different, and the difference that we can see here is that in this case the 25 is missing. So what happened in format short is that the decision to put the decimal point was based on the largest value in the array. So in this case the largest value in this array or in this vector was this value, and the decision to put the decimal point was based on this particular value. So when a decimal was put at this particular position, which is here, then what happened that due to this short format only 4 digits after the decimal are represented, and due to this we do not see 25 or 56 or 255 in either of these 3 elements of the vector. But in the same case, when we use the format long, we can easily see where the 25 lies, where the 56 lies, and where the 255 lies. So you can see that in the case of long, it is keeping the same scaled factor out of the vector, but within the vector the elements have more digits after the decimal. That is why we can see these numbers 25 or 56 appearing in the elements. Now we check how it will be represented in engineering format. So for that we will change it to format. Let's say we will first see the format short E only, and then we check the X. Okay, so just for comparison we will check the format in X format also. Okay, so this is what it is. In the case of the default format where we looked at the value of X, we were getting this, and these elements were appearing as if they were 0 because we were able to see only 4 digits after the decimal point. But when the same data is represented in the format short, which is format short E, that is the engineering short format, we see these data in this form. So you can see that each of the element is raised to some power of 10, and we have at least 1 digit before decimal point in each of the elements. So you can see that here also we have 2 before the decimal point, here also we have 5 before the decimal point. So the point is that the power is changed with each of the elements, but the significant bits are not ignored as has been done in this case. So you see the difference clearly here. Now if we present the same thing in format long E, this is format long E, and then we present the value E. So you see that what happened is that this entire power thing where we were raising 10 to the power something, and this was in the short format and this was in the short engineering format, this entire is now replaced as this, because in the case of long we have the liberty to put 14 digits after the decimal point. So that is what happening here. We are having 14 digits after the decimal point, and after that we are having as usual the power of e raised to 1, power of 10 raised to 1, as it was in the case of short format of engineering. So only difference between short form e and long form e is that the number of digits after the decimal point have increased. One more type of format is format short g. So let us check what it is. If we do format short g and then we check the value of x, so this we can see how beautifully it is representing the numbers. In the case of using format short g, it keeps the numbers in readable form, in human readable form as much as it can. So you see 25 is something which is easy to read. We can easily see 25, 56, 255. These are easily comprehensible to us, and the large number that was there in the array or in the vector, it has been written using the numbers and raised to some power. So this is the difference between using format short g. It actually presents the data in more human readable form, and the engineering versions are more about making them representable as well as easy for understanding the calculations also. Now to understand the difference between these two commands, we will take one more vector. So in this case, in this vector, the elements that we have, they had differences between the difference between the smallest and the largest element was very huge. You see the smallest element was 25 and the largest element was very large. Now we take an example where this difference is not that much big as it was in the case of x vector, and see how these formats are behaving in this particular case. So now when we run it, y equals to this, we get the output as we gave the input. So it is as it is. While in the case of the vector x, it was not the case. When we have entered the vector x, the elements, they were presented like this in the short form, where they have taken, where the MATLAB has taken out a very large common factor out of all the elements, and the decision to take out this much big of a factor out of all the elements was based on the largest element in the vector. So it was done in the short format, which is the default format. And again here also the format is format is not default, but we will make the format default, and then we will see what is y. So in the case of default format, which was short, we can see here again that the common factor has been taken out of all the elements, and the decision to take this common factor out, that is 10 to the power 3, it is based on the largest element in the vector, so which was 1072. So it took out this much of value. Now when we change this format and we see how it is being represented in format short e. So remember that short e, short space small e, short capital E, and short capital E and G are all the same commands, and they are going to do the same thing to the format of the output. Now when we do the short e command and we check how y is represented in this particular format, so in the case of engineering format, we see that we always have at least one digit before the decimal point. So the significant bit in the number is always given priority, and all the elements with a significant bit will be before the decimal place, and accordingly it will be multiplied with powers. And if we do the format long e, and then we check the y, so it is not going to make any change except for the fact that we will have more number of digits after the decimal. So we see that it is almost identical to short engineering format, and the only difference being that after the decimal point we will have more number of digits than compared with the short engineering format. But the important thing which we can see is in the format short g. In this format we will see that the data will be exactly what we have given as input to the vector, and this is happening because in the case of format short g, it represents the data in a more human readable format and tries not to take out or simplify it in any ways as it is being done in the case of short, or in the case of short E or long engineering. So that's it for today, and thank you.